Hi everyone, this is Professor Mayungar and you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Let's get started. Hello viewers, today I'm going to show finite element analysis of a member which is having 15 elements, and the top and bottom side of this one is actually insulated, and from left hand side and right hand side you will be having different temperatures, right? And that will be done using ANSYS mechanical APDL. Let us see the statement of the problem. For the body shown in figure, determine the temperature distribution. The body is insulated along the top and bottom edges. Thermal conductivity is equal to 1.7307 watt per meter degree centigrade, and no internal heat generation is present. So you can see this is the model. In this model you can see total 15 numbers of nodes to be created, and it will be having total 8 numbers of elements. And the total length of the member equal to 8 centimeter, that is equal to 0.08 meter, and height of this one actually 5 centimeter, that is 0.05 meter. While making a single element, we need to move along x direction by 0.02 meter, and along y it will be 0.025 meter, right? So without wasting time, let us move on to ANSYS mechanical APDL for analyzing this one, right? So first of all, we need to create a directory, and in that directory we need to save everything. Next to that, we can change the title of this one, and title can be named as FEA 12, and the title can be seen at the lower left corner. That can be viewed from plot replot. Now the title is visible at the lower left corner, right? Okay, first of all we need to know what type of analysis it is, and that can be obtained from preferences. It is definitely a thermal analysis, so thermal analysis is clicked in. Okay, next to that we need to define elemental properties, and that will come from preprocessors. Element type, add, edit, delete. We have to add it, and in this case we are considering solid, and by default it is taking quad 4 node 55. Okay, let us close it. Next to that we need to provide material properties. Material models, thermal conductivity and isotropic. Thermal conductivity is 1.7307 watt per meter degree centigrade, right? Okay, next to that we need to start modeling, and as I told before, the total length of the member is 8 centimeter, that is 0.08 meter, and within this one we need to create total 15 numbers of elements. So we have already seen the model. Let us start modeling. Let us create nodes, right? And it will be in active coordinate system. First node will be created at the origin, so apply. Second node will be created at a distance of 0.02 meter from left hand side, apply. Third node will be created at a distance of 0.04 meter, apply. Fourth node will be created at a distance of 0.06 meter, apply. And fifth node will be created at a distance of 0.08 meter, apply. The series, it will be continuing in the upward direction again. So next node, the sixth node will be at a distance of x equal to 0 and y equal to 0.025, apply. Then next one, it will be 0.02x and y equal to 0.025, apply. Next one will be 0.04, y equal to 0.025, apply. Again next one 0.06, y equal to 0.025, apply. Then in this row, last one will be 0.08 and y equal to 0.025, apply. This row is complete. Again we need to go up with a different value of y. So in the top level, first node will be at x equal to 0 and y equal to 0.05 meter, apply. In the top level, second node will be at a distance of 0.02 meter along x, and along y it will be 0.05. Apply. Next one will be 0.04 and y equal to 0.05. Apply. Next one 0.06 and y equal to 0.05. Apply. And finally the last one is 0.08 and y equal to 0.05. Okay, so we got total 15 numbers of nodes, right? And all these nodes to be connected in the form of elements. So we can create elements auto numbered through nodes. We can join node 1, 2, 7, 6. That will comprise element number 1. Second element we can start from 7, 12, 11, 6. Apply. Third node we can consider 2, 3, 8, 7. Apply. Fourth one we can create from 7, 8, 13, 12. Apply. Next one it will be starting from 3, 4, 9, 8. Apply. And again 8, 9, 14, 13. Apply. Again 4, 5, 10, 9. Apply. And the last one is 9, 10, 15, 14. Okay, so we made all the elements. It is having total 15 nodes and total 8 different elements are there, right? We need to find out temperature distribution through different nodes, right? So our model is ready. As we have done this model with nodes, we need not mesh it. So next to that we need to apply our boundary conditions, and that will be coming from loads. Analysis type, it is a new analysis and we are considering steady state analysis. Define loads. Apply thermal temperature. Apply thermal temperature on nodes. Left hand side will be having temperature of 40 degrees centigrade and right hand side will be having temperature of minus 20 degrees centigrade, right? So first of all we need to apply temperature at the left hand side. It will be 40 degrees centigrade. Let us select nodes. Nodes are selected. Apply. It will be having temperature of 40 degrees centigrade. Apply. And at the extreme right hand side temperature will be minus 20 degrees centigrade. So select nodes 5, 10 and 15 we are selecting. Okay, and temperature will be minus 20 degrees centigrade. Okay, done. Now the top and bottom surface should be actually insulated. That will be different from here. Heat flux on nodes. Let us select node number 11, 12, 13, 14 and 15. Apply. It will have constant heat flux of 0. Okay. Similarly at the bottom side also it will be having same constant heat flux of 0. So let us apply this one again. All the nodes are selected. Okay, and constant heat flux will be 0. So all the boundary conditions are applied. We have provided left hand side at a temperature of 40 degrees centigrade, right hand side temperature is minus 20 degrees centigrade, and top and bottom sides are actually insulated. So boundary conditions are applied. Next to that we need to solve it. So solution, solve current LS. If everything is right, it will show solution is done. Let us see what it is. Solution is done, so everything is perfect. Now we can see our results from general post processing, right? Let us close it. General post processing, plot results. Can do plot nodal solution. We want to see temperature at different nodes, right? Nodal temperature. Okay, this is the temperature distribution. Another thing is we can see this distribution in a different form also, like in the form of listing also. That means at a defined nodes we can see the temperatures at in the form of numbers, right? From here it is clearly understood that at first node temperature is 40 degrees centigrade, and as it is approaching towards right hand side, temperature is decreasing. At the last node temperature is minus 20 degrees centigrade, and in between it is having different temperatures, right? And to have the temperature in a better way, let us see list results, right? So list results, nodal solution, nodal temperature. Okay, so this is providing total temperature at different 15 nodes. So here in this case we will have 3 set of results, all will be same. So 1 to 5 it is having one set, and it will be repeating again from 6 to 10, and again 11 to 15 it will be repeating. The thing is we are having 3 equal sets, right? So we can say first node temperature is 40 degrees centigrade, second node temperature is 25 degrees centigrade, third node is 10 degrees centigrade, fourth is minus 5 degrees centigrade, and fifth one is minus 20 degrees centigrade. Now the same thing will be repeating if we are moving up from this one. Let us see, it will be better to see this one in the form of listing results, and let us see the nodes also. So plot nodes, and you can see the numbers of nodes also that can be viewed from here. Plot controls, numbering, and you can name the numbers of nodes. It is off, we can make it on, right? You can see the nodes at different locations and numbers with numbers. You can see numbers 6, 7, 8, 9, 10 all are equivalent to the node numbers 1, 2, 3, 4, 5. So these parallel nodes will be having same temperature, because from left hand side we are providing temperature of 40 degrees centigrade, and right hand side it will be having temperature of minus 20 degrees centigrade. It will be equal values. Node 1, node 6 and node 11 will be having same temperature of 40 degrees centigrade. Similarly, node 2, node 7 and node 12 will have temperature of 25 degrees centigrade. Node 3, node 8 and node 13 will have temperature of 10 degrees centigrade. Then node 4, node 9 and node 14 will be having temperature of minus 5 degrees centigrade. And finally, node 5, node 10 and node 15 will have temperature of minus 20 degrees centigrade, right? As this is the result, so we can save this one from here, file, save it, right? We are not saving, but we can save it. Let us close this one. Now I want to see the animation of this one. So plot elements again, and let us see the plot results. Nodal solution, control plot. Okay, this is the temperature distribution from left hand side to right hand side. Now to see the animation of this one, that can be viewed from plot controls, animate, and we want to see deform results. And our task will be to see temperature from left hand side to right hand side. You can see this one as forward only. You can see temperature distribution, how it is moving from left hand side to right hand side. Okay, let us close this one. So this is all about our today's video. This was a very simple analysis of a member which is having total 15 numbers of nodes, and in this case we provided constant temperature at left hand side equal to 40 degrees centigrade, and right hand side we have provided temperature of minus 20 degrees centigrade, and top and bottom sides are insulated. We could find the temperature at different interfaces also, right? And we could see the temperature distribution throughout this member. Okay, so this one will conclude our today's video. Thank you so much for watching this video. Thank you again. Bye. If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.